Hello and welcome for the first lecture on artificial intelligence in robotics. My name is Jan Feigl and I am one of the lecturers for this robotic course. In this first lecture, I will provide you an overview of the course organization, and then we will switch to introduction to robotics. What are the robots? Is the robotics? What are the challenges in robotics? And in the end, I will briefly cover a locomotion topic that you will enjoy during the labs. The Artificial Intelligence in Robotics course has web pages on the faculty courseware where you can find information about the teachers, classification, that is quite important, I will cover it in a few seconds. Also the tasks that are required to fulfill to actually achieve the classification, and also the overview of the laboratory exercises, and finally, and most importantly, the lectures. So all the lectures are already available at the website. I will continuously update these slides, and it's more than recommended to actually go through the slides and eventually go through the pre-recorded lectures, and then we can spend the actual lecture in a discussion and answering your questions. Finally, there are some tutorials, especially for the libraries and simulations environment that we will use. And here for students, you will find the topics and questions for the exam. But here also will be linked the recorded videos for the lectures. So my name is Jan Feigl. I'm from Computer Science Department, where I'm working in Artificial Intelligence Center, and together with Pavel Rytíř, who will be mostly responsible for the game theory part of the course, who is also from the Department of Computer Science and Artificial Intelligence Center, we will provide you the lectures. And regarding my background, I am heading the Computational Robotics Lab, and I also co-found the Center for Robotics and Autonomous Systems, you probably are aware of. And in the case you have any questions regarding the artificial intelligence or robotics, ask me or Pavel, and we can point you to some our colleagues, or if you are interested in working in the labs as well, just ask, and we can point you to particular research group at the Charles Square campus. So what are the goals of this course? So first of all, it's targeted to master yourself with applying artificial intelligence methods in robotic tasks. And this will be mostly through the labs, homeworks, and project, and finally also the exam. We really like that you will become familiar with the notion of intelligent robotics and autonomous systems, and you will acquire hopefully deep knowledge about robotic data collection planning, which is one of the strength, or I would like to one of the strong part of the research happening at the Charles Square, and it's also expected that you will acquire experience on combining different approaches in autonomous robot control programs, because the integration of existing, including implementation of algorithms in mission planning software and robot control program is an essential part of robotics, because a robot is very complex system, and you can actually enjoy and utilize existing solutions. So finally, you will hopefully have experience on solution of robotic problems, and you will have this hands-on experience, that your own experience, that you touch the robots and you touch the problems. So regarding the course organization and evaluation, you are probably aware that artificial intelligence in robotics course is in Czech and English version, but it's teach together. The differences are in the labs. We are also aware that the teaching during the teaching weeks is split to 2 hours for the lectures and 2 hours for the labs. These are the 45 minutes long hours. And by means of completion, you need to gain the ungraded assessment and exam. And if you pass, you gain 6 credits. And just be aware that one ECTS credit is about 25 up to 30 hours, so which is 180 hours in the total, 60 minutes hours. And the organization of the course is that you have 3 hours per week spent on lectures and labs, so which is 32 hours in the total. We estimate the exam, including the preparation, will take you 10 hours, so exam is 1 hour for the test, and you will need probably to go over the slides and the studying material. So the main workload is during the teaching part of the semester, so task and project, and it's expected to deliver about 9 hours per week. Based on the last year, we calculate what is the median of the workload, and it is actually what the students report is below this 9 hours. So the most of the work is during the semester, the labs, tasks, homeworks, and semester project. There will be just the exam test in the end, and you should attend the labs. You should use the contact time with the lecturers and the teachers, even that it will be remotely online, because you need to successfully pass all the homeworks and semester project. The important part are resources and literature. There are a couple of textbooks I can recommend. So the first part for the background and context is covered in 2 introductory textbooks, Introduction to AI Robotics by Robin Murphy and Robotics Primer by Maja Mataric. And the Bible of robotic planning is the Stephen Laval's book, Planning Algorithms, that you may also find online in PDF. And recently there is good textbook, very nice textbook on modern robotics, mechanics, planning and control. This is also worth of reading, but this doesn't cover the artificial intelligence part. This is more like providing the background for the traditional, let's say, robotics, but it is essential as well. So then you will have lectures that are basically comments on the textbooks, slides, and of course your notes. And there will be a couple of selected research papers for that will be specified during the course, where you can find additional information, and if you are particularly interested in the specific topic. Because the course itself is to provide you the idea about the problems that we are able to solve, what are the challenges we need to solve, and the top-notch results are not covered in the textbooks. They are usually covered in the papers. So I will go to that later. So there are also further textbooks that I can recommend you, but that's not super mandatory. There is Principles of Robot Motion, Theory, Algorithms, and Implementations. I would say that it covers a part of what is covered in the previous textbooks, but the style is a little bit different. So take a look to these textbooks and just verify what will be the style you actually like. There is also Introduction to Autonomous Mobile Robots, which is relatively easy to read. There is like the providing you the background to mobile robotics. And I would also recommend you the Computational Principles of Mobile Robotics. I guess that there is the second edition at least, by Gregory Dudek and Michael Jenkins, and it's also provide you the background for the robotics, and in this sense what is what we can solve and what is the computational necessary tools to that. And finally, this is less related to the artificial intelligence in robotics course, but it's also nice just to be aware of that. There is robot motion planning and control by Jean-Paul Lamont. You can find it online, and this is specifically targeted to the control and related motion planning. It's more control oriented. Regarding the fundamental approach for autonomous robots using localization and stuff like that, the probabilistic robotics is one of the Bible of the autonomous robotics. And if you are more about vision, eventually connected with the control for the robots, the textbook by Peter Cork is also worth of looking. So for the winter semester this academic year, we have 14 teaching weeks, but as usual we will have only 13 lectures because there is Saint Wenceslas Day on the Monday for this year. So you will have a time to actually acquire some of the information from the textbooks. Okay, so teachers, the lab supervisor is Petr Čížek, who is experienced roboteer, also participating in the DARPA Subterranean Challenge. So enjoy his presence and ask him for the details. For the first part, you will meet Miloš Prager, who is working on mobile robot exploration, and I will specifically point it that if you are interested in the semester project regarding the information theory-based exploration approaches, ask him because he is the guy. For the multi-goal planning, we have the expert Peter Vanya, who is let's say leading guy in curvature constraint multi-goal planning. So if you are interested in this part of the course, this is the right guy to ask any details and thoughts about that. And finally, for the game theory part, you will meet David Milec, who is expert in game theory and also applying these in the robotics task you will enjoy as homeworks. So for the communication, just to remind that you can use the email. That's probably the best communication. You should use your faculty email. Put the abbreviations of the course just to quickly touch the email. And if you are not sure who is the right teacher, you can use this alias that will be delivered. The email will be delivered to all of us. So regarding the computers and development tools, you already have prepared the computer labs of the Department of Computer Science, where all the necessary tools are pre-installed, but you can also enjoy your own working environment. Most of the tasks can be done in Python, or if you prefer the C++, especially regarding the speed, not speed of the implementation, but the performance. We will use the Coppelia Sim robotic simulator, which is successor of the VREP we previously used, but basically it's the same for now. And for the motion planning and asymptotically optimal motion planning, you should become familiar with the Open Motion Planning library, because there are most of the algorithms already available. And we will also provide you sources and libraries provided by the Computational Robotics Lab and Game Theory Group, or any other open source libraries you can use. You can enjoy the faculty GitLab, and we will use also for a couple of the organization stuff the Google Apps for Education that is related to our faculty, and you should already be familiar with it, but once you are like the Erasmus students here, or from Prague AI, from different universities, so just be aware that we are using Google Apps for Education for many things. So now regarding the other information resources, probably you already know that as a member of the academic society, you have access to IEEE Explore, Science Direct, Spring Link, where you can find the journals and articles in these journals. And some of the journals as resources regarding the robotics, you should be aware that there exists IEEE Robotics and Automation Letters, Transactional Robotics, International Journal of Robotics Research, Journal of Field Robotics, newly coming Field Robotics, Journal Robotics and Autonomous Systems, Autonomous Robots. There is also a related conferences such as International Conference on Intelligent Robots and Systems, IROS, RSS, Robotics, Science and Systems, and ICRA, even European Mobile Conference on Mobile Robots. And that's the platform where you can find the most latest results on these conferences regarding the robotics or the AI part. But regarding the robotics, and in these journals, the letters are also quick for you can touch what is related, and these are more matured results. Okay. So, task, labs, homeworks, and project. So there are several tasks and assignments. I will upload it to the Brute system. There is mandatory homeworks for 50 points, organized up to 50 points. Organized in 4 thematic topics. So there is the first is autonomous robotic information gathering, which is mostly building the building blocks for the project. It will be under exploration, so you will control the robot, you will touch the sensing and mapping. There is another topic related to multi-goal planning. There is randomized sampling-based planning methods, which are fundamental. And we have relatively large by means of points you can gain. Game theory in robotics, but that's because the other parts, especially the first topic, is covered in the project where you can gain up to 30 points. And there is one bonus task within the first topic team, that's incremental path planning. You can gain 5 points. Okay, so what are the tasks? Labs, and it's expected that you will finish the task during the labs, or if not, then that's your homework, and you have 9 hours per week. So there will be open loop robot motion control, reactive obstacle avoidance, map building, and grid-based path planning, and then you will put it to very simple mobile robot exploration, but not in the fully deployable way. Then there is the accompanied incremental path planning. These are light. You will become familiar from the lectures. The second team is multi-go path planning, which is mostly like TSP problems, formulations. There is traveling salesman problem with neighborhoods, and a commercial constraint multi-goal planning, which is a Dubin's traveling salesman problem with neighborhoods. And you will become familiar with the solutions for these problems. Then we will switch to randomized sampling base, because that's our essential for motion planning of very complex systems such as traveling robots or even robotic manipulators. And for this second, which is 7 points, and it's expected that you will deploy the asymptotically optimal sampling-based motion planning to robotic manipulator to also touch not only mobile robots but also the robotic manipulators. And for the game theory in robotics, there are 4 tasks: greedy policy in pursuit evasion, Monte Carlo research policy, value iteration policy, and finally in patterning in polygonal environment that you can enjoy, let's say, not reactive based decision making, but with some thoughts about what if can be made. So that's provide you the let's say more intelligence to your robots. So all tasks must be submitted to avoid the ungraded assessment, and late submissions are penalized. So we really aim to that you will deliver the task in time, because you have only 9 hours per week. So if you don't spend on this task, then you will be overloaded. So, and we don't like that. So submit as fast as you can. And the minimal scoring for the homeworks is 30 points. So it's the sum is more, but you need at least 30 points. The project is autonomous robotic information gathering, and you can receive up to 30 points. It's expected that you will implement 4 exploration pipeline, and primarily targeted to the Coppelia simulation environment, which you can run on your personal computers. And if you will be interested, maybe you can also deploy it on the real robots, but it's not that convenient if you don't have the robots in the home. Anyway, it's relatively low number of points you need to receive at the minimal scoring, so 10 points. And it can be basically achieved by deployment of the first task into autonomous exploration pipeline, but must be perfect. So it's highly recommended that you will extend that, and there are multiple options how you can extend the exploration framework. You can consider multi-robot exploration. You will have the background from the lecturers, and consider advanced exploration strategies, not just greedy nearest frontier or so. You can consider MinPose or MCTS-based task allocation, MTSP, information theoretic based decision making, distributed and decentralized approaches, and so on. And the deadline for the project is before the Christmas, because we really like that you will focus after that on the game theory tasks. So, and also early delivery means that you will have sooner the response from the teacher about the expected or possible scoring. So what is the course evaluation? You have up to 110 points. So from the homeworks you can gain this, but it's minimum required that. You have bonus homework, it's highly recommended, but you don't need to do that unless you are so penalized from the late submission of the homeworks that you will need that. From the project you need 10 points, but you can gain much more. And for the exam you need 20, or you can achieve 20, but you need 10. So in the sum you need 50, which is the E. So it's not super nice, but you can eventually pass. Okay. Is the grading sufficient? Please target to excellent. Let's take a look to the lectures. So the next week is St. Wenceslas Day. Then we will continue with robotics paradigms and control architectures, which is, in my opinion, quite important to provide you the background, because maybe so far you apply the AI methods individually on isolated problems, but within the robotic system you need to put the particular methods for the whole architecture. Then we will follow with the path planning, and if you are already familiar with search-based methods, we will mostly use them, but I will also show you some advanced planning techniques specifically designed for path planning on the grid. We will continue then on robotic information gathering with the representative problem on mobile robot exploration. And we will switch to multi-goal data collection planning, which is like surveillance and inspection planning. And if you like to apply these methods to curvature constraint paths that are required for area vehicles, for example, then we will cover that in on the 6th lecture. The randomized sampling-based motion planning methods are quite important because they are very successful in motion planning for, or even path planning for complex robotic systems, including multi-joint robotic arms. And then you will have 3 lectures on game theory, and then we will touch the multi-robot planning, and I'm quite not sure about the last lectures. We will see what will be possible anyway. So that's all.